Okay, problem number 20 here is a review problem from our probability unit, which was actually unit 7. But you are going to be responsible for it. So let's check it out. So this video is going to be about probability pertaining to a deck of playing cards. So let's take a look at an image of playing cards so we can refresh our memory. In this modern age of video games and social media, kids just don't play cards the way they used to. So I have to actually teach you what cards look like. It's a little bit of a shame. Anyway, what you are looking at are 52 cards divided up into what you call suits, 4 suits. All right, clubs, spades, hearts, and diamonds. So each one of these suits has 13 cards. So we have 4 sets of 13. All right, if you look at the clubs, we have 3 face cards, the jack, the queen, and the king. You know that they are face cards because they have little faces on them. All right, and of course, the ace. All right, so basically it's like 1 through 10, and then 3 face cards, that's 13 cards. 13 times 4 is 52. All right, so keep this all in mind as we look at these probability questions. Okay, you're drawing one card. What is the probability of drawing a face card or a red card? Okay, target over total, people. We want the probability of drawing a face card or a red card. So we're just going to add up all of those possibilities. So let's start with red card. How many red cards are there? Well, that's half of the cards are red. So if you look at all the red cards, that's 26, all right? 2 times 13, or half of 52. Either way, the red cards, there's 26 of them. Okay, so as we do this problem, you should be thinking, okay, this probability, target over total, all right, I've got 26 red cards so far. Now, or face cards, okay? Now, here's where you got to be careful. The most common mistake that kids will do, they will take, they see that there are 12 face cards and there are 26 red cards. So if we're doing face cards or red cards, students will often do 12 plus 26. But can't you see, if you do 12 and then you do 26, you're counting these 6 cards twice. That's no good. You just need to count them once. Alright, so we already did the red cards, that's 26. So we just need to add on the rest of the face cards, the ones that we didn't already get when we in the 26. So we got all these red cards plus 6 other face cards that are not red. So that's key. 26 plus 6 more, the 6 black face cards. That's the total number of cards that are either face cards or red cards. Okay, out of a total of 52 card deck. So 26 plus 6, that's going to be 32. So we're talking about 32 out of 52. So you can either leave this as a fraction as long as you reduce it. Alright, 32 out of 52. Okay, so that's 8/13 is one form of your answer. Okay, so you could put 8/13. Or you could turn this into a decimal percent by toggling it. So this would be moving the decimal point twice. This would be 61.5%. Running out of space. 61.5%. Okay, so that would be the answer to that question. Alright, now let's look at the next one. You're drawing one card. What's the probability of drawing a face card and a red card? Now, so when we did or, we were just adding up all of the possibilities. We wanted all of both. But when we do and, we just want the intersection, okay, just the overlapping part. So looking back at my picture, all right, the probability of drawing a face card and a red card. So we're just talking about the face cards that are red. So this is the overlap right here. We have the face cards, we got the red cards, we have 6 cards that are both at the same time. Alright, so target over total. Okay, we're talking about 6 cards out of the 52. So again, we could reduce this. So 6 out of 52. So I could say 3 out of 26 if I want. Okay, or I could decimalize it by toggling. Move the decimal twice, that's 11.5%. Alright, 11.5%. Okay, that's how we would do B. Part C, you are drawing one card. What is the probability of not drawing a red face card? So anything but a red face card. So how many red face cards are there? Alright, you see there are 6 red face cards. So if you subtract that from the total of 52, alright, I'm sure you don't need a calculator for this, but just so you have a visual, we're doing 52 minus the 6 red face cards. That leaves 46 other cards. Alright, so we're talking about a probability of 46 out of 52. Okay, and of course I could reduce it, decimalize it. So 46 out of 52. That's 23 out of 26. Which as a decimal would be 88.5%. Got to round up. Okay, so that's how you do C. Okay, for D, you're drawing 2 cards without replacement. What's the probability of drawing a queen and a 3? So if you draw 2 cards, then we're going to take each probability and multiply. Okay, so the probability of drawing a queen, well, there are 4 queens. I feel like I should zoom in right now. Okay, we have 4 queens out of a total of 52 cards. Alright, so we pull out that queen. Now that queen's gone. Now we need the probability of pulling a 3. Now it said without replacement, so we do not put the queen back in the deck, and we reach for the 3. Now there are 4 3s, okay, but they're not 52 cards anymore. Now there are 51. So this calculation will give us the probability of pulling out these 2 cards in a row. Alright, so 4 out of 52 times 4 out of 51. Okay, so that's 4 out of 663. Okay, now be careful, if you're going to write a percent, be careful how you move the decimal. That decimal gets moved 2 places. Alright, 1, 2. Okay, so that decimal is going to end up right here. So that is going to be 0.6. Alright, so that's 0.6%. Okay, that sound was my alarm saying that it was 5 a.m. It was time to wake up. But I've been up for a while, people. Alright, so that was D. Now for E, you are drawing 2 cards with replacement this time. What's the probability of drawing a queen and a 3 now? Alright, so it's almost the same thing, but this time it says with replacement. So probability of drawing that queen is still 4 out of 52. But then the probability of drawing the 3 is 4 out of 52 again. Alright, because we put the queen back this time, so we still have 52 total cards to choose from. Okay, so it'll be 4 out of 52 times 4 out of 52. Okay, so that's going to be 1 out of 169. Again, the decimal goes here, 0.59%. Alright, which is pretty much 0.6% again. Maybe we need more decimals, so we'll say 0.59. The last one, let me put more decimals on it. The last one was 0.60. Okay, so there you go. Alright, last one. What is the probability that you draw a face card given that you have drawn a red card? Okay, and I'd like to add on to this to make it clear, because in all these other questions we said you're drawing 1 card, you're drawing 1 card, you're drawing 2 cards, you're drawing 2 cards. But this time they didn't say. But look, we're back to 1 card. 1 card. So they're just asking, what's the probability that it's a face card, okay, given that it is a red card. Alright, this is what they're asking. So, given that it's a red card, alright, that means our universe is becoming smaller. Okay, if we're given that it's a red card, you can ignore the top half of this deck. So how many cards are in our smaller universe? 26. Only the red cards. Okay, so whatever calculations we're going to do next, instead of dividing by 52, it's only going to be out of 26 now, alright, because we're given that it's a red card. So now we go back and look at, so what are they asking us again? What's the probability that it's going to be a face card? Okay, so looking at only the red cards, alright, because we're already given that it's a red card, how many of those are face cards? Well, of the red cards only, alright, the black cards do not exist anymore. There are 6 red cards, okay? So in a red card universe, there are 6 face cards out of a total of 26 cards. Okay, so that is how you set it up. whoa, what happened? So that's 3/13, which is 23.08%. Okay, and that is how you do probability with playing cards. Alright, I hope that was helpful to you guys, and I hope you go out and play some cards, man. Don't let them die. Play some poker maybe, but don't gamble. Don't gamble, just for fun. Alright, in fact, what else could you play? Spades. We used to play spades all the time. I don't know. What card games do you guys play? Alright, if anybody's watching this video and you play cards, in this day and age, will you post a comment and let me know what card games are people still playing other than poker, because obviously that's awesome, but no gambling. Alright, am I gonna get in trouble for this?